if here we have a battery lighting a flashlight bulb, if the battery is full of electricity and electricity comes out of one wire and the bulb uses it up and it's all converted into light, and then all the electricity goes back to the battery, there's something wrong, because the light bulb is using up all the electricity, but all of the electricity goes through without being affected and goes back into the battery, but then the battery didn't lose any, but then electricity came out of the battery and went into the bulb. But all of this is because there's a bunch of different meanings to the word electricity. There's several different things moving in here, and they all have the same name, so you think there's only one thing. And here's a quick little analogy. Let's say that the heart generates hemicity, and the hemicity rushes down these empty tubes, because every time the heart beats, you see a flow at the far ends almost instantaneously. That means that the hemicity must be going real fast through these empty tubes. And the heart is a source of hemicity. The particles of hemicity are called blood cells. And the heart creates them, but then they're used up all through the body and destroyed, but then they all go back to the heart again. And the heart can be charged up with hemicity and then discharged. But that's as silly as the explanation here. So if we get rid of the word electricity, or at least pick one definition and then stick to it and don't use any of the other ones, then a totally different picture of what electricity is emerges. Or what is going on in electrical science, how we can explain how things work. Here is a block of matter. If I rub against it and then separate, you see two different colors. I don't know if they show up really well. You see the red and the green. That's what happens when you rub a balloon on your head or comb your hair or peel Scotch tape off a roll, and you get crackling things happening, and it attracts and tries to pull back together. And if we look at that in detail, here's a piece of matter, so let's zoom in on that. Matter is atoms. Atoms are protons and electrons. So here's my zoomed in view of a piece of matter. And if I could pull the electrons out of the protons and leave them behind, I'd get this red and the green. Oh, the dots are actually green there. The video doesn't show it up very well. I can pull the red from the green, but that means that you have to break up atoms. And aren't atoms like inviolate or something? You can't break atoms except with atomic energy. No, atoms break up all the time. It's the nucleus of atoms that is really hard to break. So doing this to atoms is very easy. It happens all the time. And if we want, we can say that here's the electrons orbiting the protons. And who knows if they really do that in sync or not, but if there's an electron near a proton, the two charges cancel out. It's like sticking a north and a south pole against each other, that you don't have any magnetic field anymore. Same thing happens, put an electron against a proton, the positive and the negative are annulling each other. And what this is telling us is that matter is made out of canceled electricity, or if we don't want to use the term electricity, canceled charge. And where I got that diagram was stolen from a particular Monty Python animation in Holy Grail, or the monster in the cave. When I saw that, I thought, oh boy, I can do crystals with atoms and show the details. Or another version of the same thing, two pieces of red and green plastic. And if you can do this to matter, what does that mean? That's electric charging, electric polarization. And this really happens in matter. What does it mean if you could turn one against the other? Like if all of the reds and greens weren't connected? What would that be for an analogy in the real world? Well, if here's my a piece of matter, if I could push on the green without pushing on the red, I could do this. So I grab the green, I don't push on the red, I just push one or the other, and something happens at the far end. This is sending electrical signals along a wire. This is a crude analogy for what happens. And how can that work? You're moving the electrons of atoms without moving the protons. Well, here's another microscopic, crude view of what matter looks like. If these are all atoms, they're all protons and electrons stay around their atoms. This isn't what matter looks like. This is what insulating matter looks like. Now, a conductor is more like a tank full of liquid. The electrons aren't connected to individual atoms. The electrons wander all through the material. This is how metals actually work, and you find this stuff in college physics classes, but it's sort of passed over quickly, and most people, it doesn't stick because they still have all of their elementary school science electricity knowledge. So you don't get the idea from normal education that a block of metal is like a tank of liquid. And is this liquid electricity? Well, it depends on how you define the word electricity, but there's something inside of a conductor that can be pushed around and flow.